Okay, let's go over your mock exam questions. Okay, so now these are the exam questions that you are, these are kind of similar questions that you're going to see on your finals. Okay, and now your finals is going to be available online on the 21st, and you have it until the 22nd to finish it. So it now it really just should only take you like an hour and a half at the most. And you can use all the materials to help you. The only thing that you should not use is like your fellow classmates. You don't know if they have the right answer anyway, so you really don't want to. You really should complete this by yourself. Okay, now let's go over your mock exam application. Question number one. Okay, so we're doing number one today, and I will also post number two and number three on Blackboard uh, later. Okay, okay. Let's go over this. Johnny is experiencing some symptoms of unhappiness. He went to a therapist who would like to try a new treatment technique to see if he can feel better. Okay. Now, the therapist decided to give Johnny this new treatment X as a way to test if the therapy is a good fit for Johnny. All right, so the data follows. All right, so the high score indicates better happiness. Well, it means higher happiness levels. Okay. Okay, so you see the title is Effect of Treatment X on John's Depression Level. Okay, and over here you have depression score, and over here you have uh, on x-axis you have days. All right, so number one, what kind of design is this? Well, this kind of design is a single end design. Okay, now yeah, so it's a single end design. Number two, what is the therapist doing from day 1 to 5? Well, the therapist is trying to establish a stable baseline before introduction of the treatment. Okay. Number three, what most likely happened between number 5 and 6? So now let's take a look at this. Okay. So number five, you can see that it was a very at day number five, you can see that it was a very low score, but something happened between day 5 and day 6, and all of a sudden, Johnny's depression level score is like so much better compared to how he was before. Okay, so most likely what happened between day 5 and day 6 is that the treatment with the therapy was introduced to Johnny, and therefore we saw a rapid improvement in his depression score. Okay, number four, is the treatment X effective in treating Johnny's bad mood? Yes, it is, because you can see that right before the treatment, he was not doing very well. You know, his scores were very low. But then after that, after introduction of the treatment, his score went very high. Okay. Number five, what most likely happened between day 10 and 11? So where is day 10? Day 10 is here, 11 is here. Okay. So day 10 is, well, day 10 is basically when the treatment was withdrawal. Okay, withdrawn from and then this is why you can see that in the absence of the treatment, you can see that the depression score went back down. Okay, so what kind of design is this? Let's go back to number one. So this would be a A B design. Okay, A B design. Uh, okay, so number six, what is happening to Johnny during day 14 and day 17? Well, he is really experiencing something that is very unhappy because due to the withdrawal of the treatment X. Okay. Number eight, is there anything not quite ethical about this current study? Well, let's go back to the text. Okay. is there anything unethical? Well, if there's anything unethical, is that we don't know if this treatment X is approved by, let's say, FDA or something like that, because that doesn't say anything here, right? So that is the part that is not quite ethical. That's the first part. And the second part that's not quite ethical is what? Okay. Look how many days the therapist allowed Johnny to stay in this horrible mood. So day 14, day 15, day 16, 4 days straight. What happens if Johnny commits suicide during that time? Who is going to be responsible for that? So that is another part that is not quite ethical uh, for on the therapist part. Okay, that is the second part that is not quite ethical with this study. All right. Okay, so I think that's about it for this question. Now let's talk about the next question. Okay. All right. A researcher is interested in knowing whether if age and gender of people can influence the amount of exercise. Okay. He performed a very long-term study in which he followed the same group of people from when they were in their teens to 40s of age. Okay. He then asked if the subjects to estimate how much time do they normally spend exercising per week, and then the data are down here below. Okay, now let's take a look at this. Okay, so these are the data. Time. So the title is "Time Spent Exercising as a Function of Gender and Age." Okay, in male you have it in blue, and female you have it in orange. X-axis, what you're seeing is the age, okay, in terms of years of age. And then on the y-axis, what you're seeing is the time spent in exercising per week, okay, so which is hours. Okay, number one, what is the independent variables? Okay, so there are two independent variables, okay, age of the participants, and the second one is the sex of the participants, okay? Number two, what is a dependent variable? Well, the dependent variable is exactly what it says here. Time spent in exercise per week, well, in hours, okay? And number three, what is the design of the current study? Okay, so this design is, well, I'll write it down here. Okay, so this design is a 4-by-2 factorial design, longitudinal, geez, I can, longitudinal design, which is also a repeat and measure design. Okay. Okay. Number four, what is the scale of measurement of the dependent variable? Okay, so the dependent variable is the number of hours, right? So what is that? Does it have an absolute zero? Is it possible that they spend no time, absolutely no time in exercising? It's possible, right? So it has an absolute zero, therefore it's a ratio. Okay. The scale measurement is ratio for number four. Number five, what is the nature of the independent variable? So okay, so in terms of age, the nature of the independent variable is continuous. Okay, because it's a number of years. Okay, and 30 years of age is exactly 2 times more in as 15 years of age. Okay, so it runs on the same spectrum, so therefore it's continuous. Okay, and so that's the age. Now, what about the gender? The gender is discrete, right? Because it's indivisible. Okay, so that's that. Um, let's see what else. I think number three and number six is just a duplicate. Okay, so we can just skip that. We answered that already. Number seven, by just looking at the graph, is there okay now? Is there an overall main effect of age? Okay, now let's just compare number something like 15 versus 45. just overall, is there like a difference in the amount of the time that people are spending exercising? It looks like there is, right? So you can see that at least when we don't know about 25 to 35 and all that, but when you're looking at just 15 versus 45, there seems to be a significant decline, right? Because the error bars are not really matching. So the error bar for the upper limit is here, and the error bar and the lower limit is here. There, they don't overlap. So there is going to be at least, this pair is going to be at least significant. So there is going to be an overwhelming effect of age. Okay, so that's the first one. What about the overall main effect of gender? Okay, so what you are looking at is there a significant difference when it comes to male and female and in overall? Okay, so you can see that at 15 we don't see a difference. At 45 we don't see a difference between male versus female, but at 25 and at 35 what we are seeing is a huge disparity when it comes to the amount of time they spend in the gym, what they spend exercising in males compared to females. And males definitely spending a lot more time, because you can see that the disparity between at 25 and 35 in males versus females, the males are spending so much more time. So you can safely say that just by looking at the graph, and most likely there is also an overwhelming effect of um, sex on the time spent in exercising per week. Okay, number 7C, is there an interaction effect? Okay, so there isn't an interaction effect, and how can we tell? Because right away you can see that the effect, and the way that you want to tell this is actually quite easy, because you can look at something like male versus female in 15 versus male versus female at 25. Okay, and so you can see that the comparison in just male versus female in 15, they're not significantly different from one another. And when they get to 25 years of age, all of a sudden male and female are significantly different from one another. And you can see that the slope is different, right? This is by in no means parallels in terms of slope. Right? So you can say, just by looking at the graph, you can say that there is definitely an interaction effect already. Okay, and so there is definitely so by all of these three, this is the case. Okay, so this is how you look. This is how you do data exploration when you are doing this kind of when you're looking at the graph. Just by looking at the graph, you can get a good idea what kind of effect, what kind of overall main effect as well as interaction effect that you are looking at. Okay, number 8, which group or condition had the highest variability? Okay, and which one has the lowest variability? Okay, and how can you tell? Well, the way that you can tell is really by looking at how big the error bars are. Okay, the bigger the error bars, the more variability there is. Okay, the smaller error bars, the smaller the variability there is. Okay, so it looks like the smallest error bar that we see is here, female at 35 years of age. Okay, and the largest, the biggest error bar that we're seeing is the male at 35 years of age. Okay, so male at 35 years of age is where we see the most heterogeneous in terms of the variability. Okay, and female at 35 years of age is the most consistent. Okay, which means that they exhibit the least amount of variability in the data. Okay, number 10. Now looking at the simple main effects. Okay, so what are the simple main effects? So we're just looking at one level of something and looking at okay. So A, at the level of 15 years of age, do male and female differ in the amount of the time spent exercising? Okay, and what about at 25, at 35, at 45? Okay, so at 15, do the error bars overlap? They do. Okay, so therefore, at the level of 15 years of age, male and females, they do not differ in terms of how much time they spend exercising per week. Okay, at 25 years, yes, we see a difference. Okay, males spend significantly more time than females exercising. Okay, And same thing in 35 years of age, male spends significantly more time than females in exercising. Now, at 45 years of age, this is no longer true. Okay, male and female spend exactly the same amount of time exercising. Okay. Okay, now B, at the single level of male only. So now we don't care about the female, we're only looking at the male. Okay, so at the simple level of males only, which pair looks to be significantly different from one another? Okay, which one are not significantly different from one another? Okay, so we're only looking at male. So we're looking at 15 versus 25 years of age. Do the error bars overlap? Yes, they do. They overlap a lot. Okay. So that means 15 versus 25 in the males only, they're not significantly different from one another. What about 15 versus 35? No, it doesn't because the error bar still overlaps a lot from one another. Okay. What about 15 versus 45? Okay, so we're now seeing that the error bars do not overlap that much. Therefore, 15 versus 25, there is a significant differences. Okay, in which that 15 years of age male spend more time exercising than 45 years old male. Okay, now what about 25 versus 45? Or 35 versus 45. Okay, so in both cases, 25 and 35 versus 45 years of age, what we're looking at is both 25 and 35 years of age male spend significantly more time than 45 males in the 45 years of age range in terms of the amount of time they're spending exercising per week. Okay. Okay, so that is B. Okay, so number C. So at the simple level of females only, so we don't care about males now, we only care about the females. Which pairs look to be significantly different from one another? Which ones are not significantly different from one another? Okay, so, okay, 15 versus 25. Okay, do the error bars overlap? They don't. All right, so 15 versus 25, this is significantly different. Okay, so in which that 15 years old female spent more time exercising comparing to the 25 years female. 15 years old female also spend more time exercising than 35 years of age females and also spend more time exercising than 45 years uh, of age. Okay, now for the rest, 25 versus 35, okay, not significant. You're looking at the error bar, there's a lot of overlap. 25 versus 45, there also is a lot of overlap, which is also means they're not significant. What about 35 versus 45? It's also not significant. Okay, there's the error bars are overlapping a lot. So you can kind of conclude that for females, the amount of time that they spend exercising is the most at 15 years of age, followed by 25. And from 25 years of age and on, there is no significant increase or decrease in terms of the amount of the exercising that they are doing per week. Okay, that's it. That would be the interpretation. Okay. Uh, 11. Okay, write one or two sentence summary as if you are writing the opening sentence for the discussion section. Okay, so what you want to say is something like, what we found that, so in this, in the current study, we investigated how gender and age of the participant can influence the amount of the time that participants spend exercising. Okay, we found that there is a significant that male versus female spend different amount of time overall exercising, in which that male in general spend more time than females. This is what you can see in the trend, right? And and we also found that there is a significant effect of age, and the overall trend is that the the younger the participants are, they tend to spend a significantly more time in exercising. Okay. However, the amount of the time when it comes to the the amount of time that when it comes to spending and the time of gym, it really depends on in what age bracket. At 15 or at 45 years of age, male and females do not significantly spend that different amount of time at the gym. However, at 25 and 35 years of age, males spend significantly more time exercising than the females. Okay, so that's how you want to say something um, for your exams if you were to encounter this kind of questions. All right. Okay. I think that's it for today. And if you have any questions, you can feel free to email me. Okay.